Our Python app connects to Slack over a WebSocket in socket mode. Many events arrive, but two drive the bot. App mentions in the channels and direct messages or DMs. Let's start with the mention flow. When Slack sends an app mention event, we log the user, channel, timestamp, and text. Then strip only the bot mention so the model only gets the real question. Then we decide where to reply. If the mention is already inside a thread, we reply in the same thread. If it's a new mention at the top level in the channel, we reply under that new top level thread as a message. And Slack starts a new thread there. That thread keys a conversation ID, workspace, channel, and thread, so we can load recent history from MongoDB and generate a reply from the clean text plus that history. We send the answer back as a threaded reply in the channel, not a new channel message. Bolds say helper does that. We pass the reply text and which thread to post in. Finally, we save the user and assistant turns plus lightweight state. I will show you the MongoDB side next. Now, regarding the direct message flow, DMs follow the same memory and reply pattern, but first we filter the event. We only continue if it's a real human direct message, not a channel message, not from a bot, and not a system subtype like a message edit. For DMs, we log the context, then build a conversation ID. Threaded DMs use the thread timestamp, while normal DM use one ongoing conversation per DM channel. We load the DM memory, generate a reply, and send it back. If the DM is already in a thread, we keep the reply in that thread. Otherwise, we send a new normal top level DM response. Then we finally save the turns and state. Same ideas as app mentioned, just different routing up front. Now the next step is to add memory or persistent memory for the AI to remember different conversations, turns, states, roles, and what the history has been so far. So let's add the integration after the threaded reply support. I'm going to give this task to the agentic AI in Codex GPT 5.5 thinking model to continue its task. While on the go, I will create a MongoDB Atlas checkpointer. I will sign up with Google. And now let me show you the steps in MongoDB Cloud. First of all, you need to create an organization, give it any random name, and it will work for you. I'm going to name it Slake AI and then create organization. Now we need to create a project. Let's create the project and let's name it as Lake Memory Management with the and using the camel case naming convention. And let's name this as Lake Memory Management. Now we need to create a cluster, and as we will be using the free cluster on MongoDB, so let's change this to the free one and select the region that is nearest to your location. I'm going to name it as Lake Memory Cluster and remove the preload sample database as it will take up space on the 500 MB. So let's create the deployment, verify I'm not a robot. And right when you go to this screen, it will give you the credentials for the username and password, but you need to create the database user. So you will see the green button to create the database user. Click on that and it will create your DB user. If I click choose a connection method, as I do not have the user created right now, I will get an error. But if you click on the create database user, it will work fine. So choose a connection method, gives us an error, then I will choose create database, that big green button. Okay, I got an error, set up your user permission. The ID didn't create it. Let's click again, create database user. The user was created successfully. Now choose a connection method. In our use case, we are going to use drivers as we are using Python. So we will be using the MongoDB Python driver to access that. You need to install the package or the driver that is listed as above. You need to copy that and paste it in your CMD to install it, and you can see all of the connection code is also given, which you can use to integrate it. Now I will install the package PyMongo, and once this is installed, I will pip freeze to update the requirement files. Okay, once the requirement files are updated, let's clear this up and update our MongoDB URI. So this is our resource identifier, and it is a connection string that I have added into the .env file. Remember, you have to use these key for the system to run perfectly on your machine. Now what the AI agent did was it created it in SQLite, but we are using MongoDB, so I'm going to tell the AI agent to convert or update it into MongoDB. It is pretty much simple, straightforward conversation history management. Like we have the different roles it have to manage, then we have the different state and how many maximum tons it should take into consideration. So most of it is done by the agentic AI using Codex, and once that is done, it will be good to go. Right now we are not using any LangChain, LangGraph or any agentic tool. We are using simple plain linear input output flow right now. So once that is done, then we can move to agentic AI and integrate other tools like LangChain, LangGraph and many others. So now as agentic AI have completed the task, now let's test to see how it works. Now let's test it in Slack. First of all, I'm going to test with direct messages. I'm going to reply in a thread in the direct messages, and let's say what are some things you can help me with. And now let's see if I get a reply. Most probably I will get a reply, and it gave me a very general response because the assistant is a general one. It doesn't have any specific business information, neither it is directed towards a specific case. So now I will say, okay, can you translate between different languages? So it is saying, tell me about your language. I'm going to say English to Urdu. So it is going to, remember what the task is right now based on the conversation history. So now if I say translate this, it is automatically going to know. Even if I say I am an engineer and pass it forward, it is going to translate it because based on the conversation history, it does know what the current task is at hand. This is between a direct message and within a thread. Now if I go to a channel, okay, and let's add this AI chatbot in this new channel. As it's not here, so Slack bot will be asking me to add it. Now I have invited it, and now let me send a message. So I have mentioned it and said hello, and it replied. Now I'm not going to mention the AI, and I'm not going to get a reply because in a channel you have to mention AI or the app for it to respond you back. So I'm going to say I'm going to looking to translate between English and Pashto maybe, yeah, and mention the AI chatbot in my reply. So as I have mentioned it, now I will get a response back. So it is asking me whether you want to translate between English to Arabic or Arabic to English. Depending on what I want, I will just pass it. My name is Aymal, and I think the AI is intelligent enough to translate this into Arabic based on the conversation history. So the MongoDB conversation history is working, as I didn't had mentioned it, so it didn't reply. Now if I mention it and say my name is Amal, it will translate it into Arabic, Ismi Ayman. So it means my name is Aymal in Arabic. Now let's do a recap of how it works with MongoDB and the whole architecture. So Slack sends events to main.py over the socket mode. Each message runs 5 steps: parse, load memory, generate a reply, post to Slack, and then finally save it in MongoDB. MongoDB keeps history across restarts. Now the next step is parsing the event. Main.py reads the event, strips the bot mention, and picks the thread. Conversation ID for event builds a stable key from workspace, channel, and thread. One memory bucket per conversation. Now, step number 2 is to load the memory history, upsert the conversation, then load the last 12 tons from MongoDB, newest first, reverse in chronological order. If MongoDB fails, the bot replies with empty history. Then in step number 3, we clean the text and history, go to generate AI reply. AI handler.py merges pre-returns with the current message, calls OpenAI and returns Slack ready test. Finally, we post to Slack using the say reply post through bolt before any database write. Channel mentions goes into the thread. DM stay top level unless already threaded. Fast reply first. And then finally, after Slack accepts the message, we save a user turn and the assistant turn, then update the conversation state. To collection conversions for metadata, conversation turns for history. Load before AI, save after Slack. So we have two collection conversations for metadata and conversation turns for history. Thank you for watching. See you in the next one.